Hi guys, this is Dr. Manjunath Chennapgod from Anveshana Academy, Bangalore, India. Dear students, in the last class we discussed some numericals on diesel cycle. Okay, so in today's class I am going to solve some more numericals on diesel cycle. Okay, numericals on diesel cycle. Okay, we have in the previous class we have derived the equation, that is air standard efficiency equation for diesel cycle, that we have done, dear students, in the previous class. Based upon the derivations we started to solve some numericals on that efficiency equation given by Rudolf Diesel. Okay, so now I will move towards next problem, that is third problem. Okay, so two engines, I will read the problem first and I will try to solve this problem step by step. Okay, now two engines are to operate on Otto cycle and diesel cycle. Okay, on diesel cycle you can see here now diesel cycle with the following data, full stop. Maximum temperature 1400 Kelvin, comma, exhaust temperature 700 Kelvin, full stop. Okay, state of air at beginning of compression is 0.1 megapascal and 300 Kelvin. Okay, full stop. Estimate the compression ratio, maximum pressures, efficiencies and rate of work output, that too for 1 kg per second of air of the respective cycle. This is the problem he has given, dear students. Now what actually he is doing, now he is taking two engines, that is Otto engine as well as diesel engine, and he has given some common data. For that common data you need to calculate compression ratio, maximum pressure ratio, efficiency and rate of work output for both the engine, both Otto and diesel engines. Now we will solve the problem step by step. So dear students, as I told, understanding problem is very important step while solving the numericals. First analyze the problem thoroughly. So now first what I will do, I will take two engines. Now he has given two engine 1 we can call, engine 2 we can say, that is engine 1 Otto engine, second one diesel engine. But he has given some data. What is the data? Maximum temperature. What is that maximum temperature? I will mark it here now. First step I will mark it here, T max is equal to 1400 Kelvin. Then exhaust temperature, that I will write it here, exhaust temperature TE is equal to 700 Kelvin. Later with the help of particular cycle, Otto or diesel cycle, I will mark whether it is T3 or T2 or T1 or what T3, whatever it is there, right? That I will mark it later. Okay, first I will take the temperature as it is now. Maximum temperature is 1400 Kelvin. Then exhaust temperature I will take it here, T is equal to 700 Kelvin. First I will try to understand the problem. Okay, fine. Now state of the beginning of compression, that means what? Beginning of compression means what? We can take the pressure of the air at the beginning of compression is 0.1 megapascal is there. That means what? 10 to the power of 6 is there. I will make it here 10 into 0.1, it becomes what? 1 bar. Then 10 to the power of 5 is not Pascal, is nothing but what? 1 bar. Hence what I can do, I can tell here now P is equal to 0.11 MPa is nothing but what? Megapascal is nothing but what? 1 bar. That P1 he has given, and also 0.1 megapascal, and he has given 300 Kelvin. That means what? T1 also he has given 300 Kelvin. Fine. So these are the data he has given common for the both the engine, and also somewhere else he has giving mass flow rate. That mass flow rate I will mark it here, m dot is equal to 1 kg per second he has given. This is the common data he has given, dear students. What you have to do now, you have to calculate, first step is what? You have to calculate what you have to calculate? Estimate the first engine. What you have to do with help of this data, you have to calculate compression ratio for Otto cycle, then maximum pressures. That means what, it may be P2 or it may be P3 or it may be P4, but maximum pressure will be P3. How it is, that I will show. That you need to calculate one thing, and also efficiency of what? Otto cycle. I will write it here, neta O, efficiency of Otto cycle. Then you have to calculate the work done by Otto cycle. Okay, for what? These all data, that is the first case. So that we will call it as a case 1. Case 1 is nothing but what? Calculating these all for a Otto cycle, that we will call it as a case 1. So you can see here now, case 1 is what? Engine working on Otto cycle. I will assume that engine is Otto cycle for this data. Similarly, second case, what you have to do? You have to calculate the same all again. Work done by diesel cycle is equal to how much? Then compression ratio is equal to how much? What is the P2? What is P3? What is P4? And what is the efficiency of the diesel cycle? These all things I need to calculate by taking these values. Then I am going to check the performance of the diesel engine. That is what? My second case. Dear students, so what I will do now? I will go with what? First case. What is that first case? Engine working on Otto cycle. If you want to solve the problem which is working on, which is Otto cycle, right? What I have to do? The first and foremost thing is what? I need to draw the PV and TS diagram. Yes. So what I will do? I will draw the PV and TS diagram. Dear students, you can see now, this is what? PV and TS diagram for what? Otto cycle. Now what I will do? I will go with what? First one, that is Otto engine. So for that, what I will do? I will draw PV and TS diagram for Otto cycle. So PV and TS diagram for Otto cycle now. So this is what my point 1. What is the point 1? He has given the some data he has given. P1 is equal to 1 bar he has given. Then what is temperature? He has given. That we can mark it here. T1 is equal to how much he has given? He has given 300 Kelvin. Then next, he has given maximum temperature. These students, you can see in the PV diagram or you can see it in the TS diagram, but you can see the variation of temperature in TS diagram. What is the maximum temperature where we can get? At 0.3. What is that value? He has given 1400. That means what we can say? He has given T3 value is equal to 1400 Kelvin, and exhaust temperature is 700 Kelvin. That means what? Where it is going to exhaust? Here, right? It will start here now, exhaust. This is nothing but what? T1 that he has already given, but exhaust temperature is given. That is how much? So you can mark it here. T4 is equal to 700 Kelvin he has given. Okay, so now P1 he has given, T1 he has given, T3 has given, T4 he has given. But you need to calculate other things. What is that? Compression ratio, other pressures, efficiency and rate of doing work per kg second of air, that we need to calculate. But here in the both cases, what he is telling, he has taken mass polarities, that is 1 kg per second of what? Air, that you have to consider it into the problem, dear students. Now this is what the problem I have taken, that too for first case I am dealing now, that is Otto cycle. I have listed the given data and I have drawn the PV and TS diagram. So now, so if you want to solve this problem, as I told dear students, there are two cases. As Otto is also there, diesel is also there. What I will do? I will deal Otto cycle, diesel cycle separately. So what all the things you have to do when it comes to compression ratio? Yes, you need to calculate compression ratio for what? Both Otto and diesel cycle with the help of a formula, with the specific formula. First thing. Second thing, if you want to calculate the rate of work, what you have to do? You have to use the work done equation for Otto cycle separately, and you have to use the work done equation for diesel cycles. Okay, now if you want to calculate the maximum pressure, so what you have to do? You have to use the conditions for Otto cycles, and you need to calculate the maximum pressure for with help of Otto cycle formula. Similarly, you need to calculate the maximum pressure with help of a diesel cycle formula. Next one, if you know all the values, then what I can do? We can calculate the efficiency for Otto cycle as well as diesel cycle. This is what? Analyzing the problem with the help of PV diagram, TS diagram and general informations. Now what you have to do then? Now this is what? Otto cycle. This auto is running on what? Auto cycles. So petrol engine we can say, or you can call gasoline engine also, we can say, dear students. Next one is what? Diesel cycle. What is that diesel cycle? When you take an example of bus, dear students. This is the data he has given. These are the two engines he has considered, one auto engine and diesel engine. For this we need to do the solutions. So how to do this now? So now what I will do, I will list out the given data. How much he has given? T1, that means what? Maximum, not T1, it is what? T3 in when it comes to auto cycle. How it is, you can see now. When I am going to draw the TS diagram, right? So that what I got, T3 is equal to what? 1400 Kelvin. That is nothing but what? Maximum temperature. That is equal to T3 has given. Initial temperature, that means what? He has given T1 is equal to 300 Kelvin. Next, exhaust temperature. So that is nothing but what? You can say T4 is equal to 700 Kelvin he has given. Then he has given P1 is equal to 0.1 megapascal he has given. That is nothing but what? In terms of bar is nothing but what? 1 bar. He has given. These are all data he has given now. So how to solve this problem? With the help of this formula. Auto cycle formula. Okay. To calculate the auto cycle formula, we work done for auto cycle, we may require heat supply. That heat supply can be calculated with the help of this equation. That is what? Q in, that is CV into, when it comes constant volume process, right? That is very important. When it comes to heat supplied and heat rejection, both are taking place at constant volume. For that purpose only we are calling auto cycle as a constant volume process. When it comes to heat calculations for constant volume process, what we have to do, I have to take the specific heat at constant volume. Okay, CV into maximum temperature and minus minimum temperature. That means what? Maximum means what? T3 minus T1 I can take. What is the value of CV? Because you can calculate T3 and T1 and you can substitute here, you can get the value of what? Heat supplied. To calculate that heat supplied, I may require the specific heat for air at constant volume. That is equal to how much? That is a constant 0.718 kilojoules per kg Kelvin. Okay, with the help of this data, what I can do now, I can calculate the efficiency of a auto cycle. This is the derived equation that we have done already. So this is the with the help of this equation, I can easily calculate the efficiency of the auto cycle. Somewhere we may require compression ratio, because in the findings he is asking to calculate the compression ratio also. To calculate that compression ratio, we are having an equation. Somewhere he is asking to calculate maximum pressure. That maximum pressure can be calculated with the help of this equation. This is what the problem we have analyzed the problem with the help of what? Given data. Now I will solve this problem step by step. Dear students, as I told, first step we have to do to compression ratio need to calculate. Next one, maximum temperature. Step by step I will solve now. First I will try to calculate the compression ratio, then maximum pressure, then efficiency of the cycle, work output, then how much of heat you have supplied. That I will calculate step by step now. So list out the given data with the help of temperatures. T3, that is maximum temperature he has given, that is 1400 Kelvin. That T4 is equal to 700 Kelvin. P1 is equal to 0.1 megapascal he has given. Convert it into bar. Then what will happen now? It is nothing but what? 1 bar. So T1 is equal to 300 Kelvin he has given. Now what I will do, I will try to solve the first step. That is what? Compression ratio. That compression ratio is represented as a RC. So we know already, dear students, what is the compression ratio? That compression ratio is ratio of V1 by V2. RC is equal to V1 by V2. So for adiabatic process now I will write it here, RC is equal to V1 by V2, and I will write it as equation number 1. Now what I will do, I will go with the adiabatic expansion process, that is 3 to 4, that we already know, right? That means that is nothing but what? Adiabatic expansion. So this is nothing but 3 to 4. There we know the temperature ratio versus volume. That is nothing but T3 by T4 is equal to V3 by V4. V4 by V3 to the 4 of what? Gamma minus 1. But dear students, when it is a constant volume process, right, that I already told many times, when it is a constant volume heat addition and heat rejection process, right? So we know V4 is equal to V1. So then V3 is equal to V2. That you can see it in the PV diagram, dear students. Okay. Okay. You can see here now. You can draw the vertical line. What is this? What we can say now? V3 is equal to V2. Then it is what? It is what? Draw vertical line. Then we are going to get V1 is equal to V4. The same thing I am putting here now. When it comes to Otto cycle, as it is a constant volume heat addition and constant volume heat rejection, V4 is equal to V1, then V3 is equal to V2. So now what I will do? I will substitute V4 and V3 value in this now. What is V4? V4 is equal to V1. What is V3? V3 is equal to V2. So I will substitute now. T3 by T4 I will keep it as it is. Then V4 is V1 I will substitute it. V3 is V2 I have substituted. But dear students, we know already. That is also you know. What is that? What is that? So RC is equal to, you can take capital RC or small RC, it's up to you, V1 by V2. So therefore, wherever V1 by V2 is there, right, I will take it as a RC. So I will mark it as a capital RC. Now, what I will do here now? So therefore, what I can do now? RC is there. RC to the power of gamma minus 1 is there. This gamma minus 1, I will shift to left side. Then what happens? 1 divided by gamma minus 1. So 1 divided by gamma minus 1. To the power of what? To the power of what? T to the power of this thing. So therefore, what is the value of RC? Try to calculate the RC value now. So T3 by T4 to the power of 1 minus gamma minus 1. Then what I will do now? So I will substitute all the values here now. Whether you know the value of T3, you have to check that. T4 you know, then you have to check. But once you know the value of this thing, right? RC is equal to what? V1 by V2. So what I will do now? T3 is what? He has given maximum temperature. Dear students, that I told. Maximum temperature also he has given. Then what? Exhaust temperature also he has given. That is T4. T3 by T4 he has given. Then gamma is nothing but what? That gamma is constant for air actually. That is what? 1.4. So therefore what I will do? T3 is equal to 1400 divided by T4, that is 700 to the power of 1 divided by 1.4 minus 1. Then do simplification. We are going to get the value of compression ratio. That compression ratio is 5.65. Then I will mark the RC is equal to 5.65. This is my first step. It is done. That too for what? Otto cycle I am doing here now. So next step, what I will do? I need to calculate the maximum temperature. To calculate that maximum temperature, I will go with the second process, that is 2 to 3. That means what? Heat addition at constant volume, V equal to C. So that is nothing but what? We know the already. P by T is equal to constant. Now I will apply this law at point 2 and 3. That means what? P2 by T2 is equal to P2 by T2 is equal to P3 by T3. With help of this relation, what I will do? I will try to take the value of P3. P3 is maximum pressure, but that I don't know. That I can calculate with the help of this condition. So therefore, what happens now? P3. I will take this 3 at left side. Then what happens now? P3 is equal to P2 into T3 by T2. You can call this as a equation number 2. Okay, I will keep it as it is. Now I will move towards to find P2, because to calculate P3 I should know the value of what? P2. To calculate that P2, one thing, and also I need to calculate the value of what? T2. To calculate this P2 and T2, what I have to do then? I have to go with what? Adiabatic process, that is 1 to 2, compression process. There we know one condition. What is that condition? The pressure variations versus volume. We have an equation. What is that? P1 by P2 is equal to V2 by V1 to the power of what? Gamma. This is the standard equation, dear students. You have to remember. That is important. Now, what is P1? He given, that is what? 1 bar. But P2 is not at all given. I will mark here P2 as it is. Then is equal to, what is V2? That V2 is also he has given. Then V1, what is V1? 5.65. That means what? What actually, dear students, that you have to see. How he has given? RC is equal to how much you got? 5.65. That RC is nothing but what? RC is equal to V1 by V2. That means what? V1 by V2 is nothing but what? V1 is equal to 1, then V2 is equal to 5.65. Sorry. Now here, what I can do now? It is nothing but what? Can I write? This is nothing but what? 5.65 divided by 1. This is nothing but what? Here you can write V1 is equal to 5.65. V2 is equal to 1 you can write. But dear students, you can see P1 by P2 to the is equal to V2 by V1 is there. What is V2? V2 is equal to 1. Yes, I have substituted 1. Then V2 by V1. V1 is equal to how much? 5.65. That I have substituted. To the power of what? Gamma value. So then what happens? Now both left and right side you can see the only unknown is P2. So there I will do simplification and I will try to calculate the value of P2. That P2 I will get it here 11.29 bar. Because I am substituting somewhere here P1 as bar itself. So I am going to get final answers here is that is P2 is equal to 11.29 bar. That is done. Next I will go with process 1 to 2. T1 by T2 is equal to one more condition, temperature variations versus pressure. We know the equation. What is that? T1 by T2 is equal to P1 by P2 to the power of gamma minus 1 divided by gamma. So now what is T1? We know already, that I will substitute, dear students. Next, but T2 I don't know. I will keep it as it is. 1 minute. Okay, then what is P1? That is 1. What is P1? P1 is equal to 1 bar he has given divided by P2 is equal to 11.29 bar to the power of what? Gamma minus 1 by gamma. 1.4 minus 1 divided by gamma. Do simplification. You are going to get T2 is equal to, after simplification, you are going to get the value of T2 is equal to pi 99.6 Kelvin. That is what T2. Once you know the value of T2, then what I can do? I can calculate the P3. How to calculate P3? We know the equation. To calculate that P3 is equal to P2 into T3 by T2. So what is P2? To calculate this P3, I should know the value of P2. That P2 already we have calculated. Where? Here. P2 you know. Yes, I have substituted. The next, what is T3 he has given in the problem itself. Yes, fine. Then T2 you already calculated. Then what you can do now? This substitute these all values T2 and P2 in equation number 2. Then what I will do? I can get the value of P3 is equal to 26.36 bar. Hence, I got the value of pressure, that is nothing but P3 is equal to 26.36 bar. This is nothing but what? I can say maximum pressure. P max I can say maximum pressure. This is what my second finding. For what? Again Otto cycle. That is done, dear students. Now once it done, next step is what? I need to calculate efficiency of the Otto cycle. To calculate the efficiency of the Otto cycles, we know the equation that equation we already derived. What is that equation? Efficiency for Otto cycle is equal to 1 minus 1 divided by RC to the power of gamma minus 1. 1 minus 1 divided by, what is the value of RC? That you already calculated in the beginning. So that you substitute to the power of 1.4 minus 1. Do simplification. We are going to get the value of efficiency for Otto cycle is 50%. That is my final answers for what? Otto cycle. That is fine. Now last step in Otto cycle is what? How much work it is going to do. That means what? How much of work it is doing per unit time. That means what? How much of power is doing. What? No, we know rate of doing work is nothing but what? Power. That power I can write it here, work done to the time. So therefore, how much he has given? Mass flow rate, he has given 1 kg per second. So with help of this data, what I can do? I can calculate the power, that is nothing but what? Rate of doing work per unit time, that per second. What is the work done? How to calculate that work done? That we know already. That is a standard general equation. What is the work done? So work done, just a minute. Okay, we know already work done is equal to QS minus QR. This is standard equation. So what is QS now? QS is equal to what? IS. When it comes to Otto cycle, both heat supplied and heat rejection will be at constant volume, but temperatures are different. So first one, heat supplied, how we can write it now? So it is nothing but what? MCV, maximum temperature T3 minus T1. So I have written MCV into T3 minus T2 minus heat rejection MCV T4 minus T1. But M is constant here. Now that is 1. I will take it 1 as it is. Then CV 0.718 maximum temperature, that is 1400 minus T2. I will substitute minus, again 1 is there. You can take it outside. Then what I have done, 0.78 is also constant, right? The whole term I have taken it outside. Then only temperatures are there, right? That I will substitute here now. Do simplification. Then you are going to get the rate of work done per second is 287.5 kilojoules per second. This is nothing but what? Power, or we can call rate of doing work per unit time. That here he was asking, that we have done, dear students. Then now what I have done? I have calculated efficiency, power output, maximum temperature, maximum pressure. I have calculated for what? Otto cycle. The first case is done now. First case is done. Okay, now next I should move towards next step, that is our next case, that is what? Engine working on diesel cycle. When it comes to engine working on diesel cycle, again I need to follow some step. Compression ratio, I need to calculate maximum pressure for diesel cycle, then I need to calculate the efficiency, then I need to calculate the work output, then I need to calculate the heat supply to the diesel engine step by step. To solve this numerical, what I have to do then? I need to draw the PV and TS diagram for a diesel cycle. When it comes to PV and TS diagram, slight changes here. What is that? 1 to 2 compression, it is adiabatic compression. But in Otto cycle, we are supplying heat at constant volume. But in diesel cycle, what we are doing now? We are supplying heat at constant pressure process. That means what? We are supplying at heat at this point. That means P2 equal to P3 equal to P. That is nothing but a constant pressure. You are supplying the heat. Okay, then also TS diagram also you can see the, again what we can see now, the whatever the conditions he has given, right, it is remain same both for petrol auto and diesel cycle. So what is P1 is equal to 1 bar. Then what is T1 is equal to 300, same conditions but cycles are different. What is P2 we don't know, I will mark it as it is. Then what about P3 is also not given, I need to find out. Then T4 exhaust temperature he has given as 700 Kelvin and he has given maximum temperature, but P3 we don't know, but he has given T3 is equal to how much? 1400 Kelvin. That we can show it in temperatures, we can show it in TS diagram, but pressure you can show it in PV diagram. While writing somewhere I will write it a temperature here also, but you try to understand. Temperatures we can mark it on TS diagram. Okay, heat addition will be at 2 to 3, that is represented as QS. Heat rejection is at 4 to 1, that is represented as a QR. This is what diesel cycle I have drawn. Then it will be easy for me to solve the problem. Dear students, what all things he has given? To calculate the work output, I should know the efficiency of the diesel, that means for diesel cycle. To calculate that efficiency, I should know the value of heat supplied RQ in. Somewhere we are supplying heat at constant pressure, but heat rejection will be at constant volume. Hence, I need the value of constant specific heat for constant volume process as well as constant pressure forces. Both are required, CP as well as CV are required. Okay, so the next maximum temperatures are required to calculate the work output and also required minimum temperature also, that is T1. So with the help of these all data, what I can do, I can calculate efficiency and also efficiency. To calculate that efficiency, RC, that is compression ratio also required, gamma valve is also required. So then what is Tmax we need to calculate? T1 he has given, that we have to list out. P1 also he has given, we have to list out. With help of pressure variations for a different process, with help of that different process, what I can do, I can calculate the maximum pressures. Okay, so now maximum pressure, to calculate the maximum pressure, P1 Tmax is required and T1 is required. How it is required, that we will see here now. What is my first finding? As I told dear students, you can see here now. What is my first finding? You can mark it. Compression ratio. I will go with what? Compression ratio. To find compression ratio, we know already from a diesel cycle, RC is equal to V1 by V2. That I will mark here as a equation number 1. So dear students, now T2 by T2 temperature variation equation, that is constant, that equation is standard. So T2 by T1 is equal to V1 by V2 to the power of what? Gamma minus 1. But I don't know the value of T2, I will keep it as it is, divided by T1 is equal to 300 Kelvin he has given. Then V1 by V2 we know already, what is that? RC is equal to V1 by V2. So V1 by V2 is RC to the power of what? Gamma minus 1. We know the value of gamma per air, that is 1.4. This I can call it as equation number 2 here now. Okay, next now, how to calculate this T2? I don't know the value of T2, but the T2 I can calculate with the help of another process, that is nothing but what? 2 to 3. What you are doing at 2 to 3? You are supplying heat at constant pressure. That you can see now. At 2 to 3, 1 minute. Yes, you can see at 2 to 3 you are supplying heat. I will take that process and I will try to calculate the value of T2. What is the condition now? When we are supplying heat at constant pressure, right? Then what we can do? I can write volume by T equal to constant. That means what? I will apply this condition at both point. V2 by T2 is equal to V3 by T3. But dear students, here I will try to take the value of T2 outside. So then what happens? T3 multiplied by V2 by V3. This we can call as equation number 3. But I will remodify this equation, that is T2 is equal to T3, but V2 by V3. Dear students, I told in the previous class also while doing the derivation, V2 by V3 we can write it in this fashion also, right? V2 by V1 multiplied V1 by V3. How it is now? But this is the same equation, right? This equation I can write it in terms of like this. V1 V1 if you get cancelled, then what happens? V2 by V3. The same equation I am writing in this fashion. So why I am writing? Because for simplification, T2 is equal to T3 is equal to, that is constant, V2 by V1. That is V2 by V1 is nothing but what? We know already. RC is equal to V1 by V2. If I want V2 by V1, then what happens? It becomes what? 1 by RC. So the same thing I have written it, Here it is V2 by V1 is there, 1 divided by RC into V1 by V3. But why it is V4? Because we know in the PV diagram, V1 is equal to V4. Wherever V1 is there, I will take it here V4. So that same thing I have written it here now. Now do simplification. That T2 is equal to 1400 divided by RC into V4 by V3. That we can call it as equation number 4. So now you got the value of T2. But T2, you not yet got the values, but you got the values of T2 in terms of RC and V4 and V3. We will do further simplification. Then we can get the value of T2. How to do that? That you can see now. To get the value of that T2, we should know the value of what? RC. But RC we have calculated somewhere else. If it is calculated, if it is calculated, it's fine. But if it is not, that also we need to calculate. But V4 and V3 we don't know, that we need to calculate. To calculate that, we are having an equation. I will apply, I will go with process 3 to 4. That means what? Adiabatic expansion. There, variation of temperature, that is T3 by T4 is equal to V4 by V3 to the 4 of what? Gamma minus 1. This is the equation, standard equation we know. Now what I will do? T3 has given, that is 1400. T4, that is 700, that is exhaust temperature. He has given to the 4 of what? Now I will take this V4 by V3 to the 4 is there, right? This side I will take. Then what happens? 1 divided by 1 gamma minus 1. This is simplification. This is V4 by V3. But here we know the value of V3 is equal to, gamma is equal to 1.4. Then do simplification. Then what happens now? This is all value. Then you are going to get 5.65. 6 is equal to V4 by V3. Okay, now this is what? V4 by V3. Now I will go with what? Equation number 4. What is the equation that I told, right? Dear students, T2 is equal to 1400 RC divided by V4 by V3. But I calculated V4 by V3. I will substitute here now. Now what will happen now? I will substitute V4 by V3 in that equation. T2 is equal to 1400 divided by RC into 5.6. But RC is also, we don't know. I will keep it as it is now. When we are going to do simplification, right? 1400 into 5.56, then we are going to get 7918.4 divided by what? RC. This you can call it as equation number 5. Now again, here also you didn't got the value of what? T2 directly, but you got the value of T2, but in terms of what? RC. Again you need to do the simplification. How to do the simplification? Now dear students, I will substitute this equation 5 into, what is equation number 2? That you can see here now. 1 minute. What is equation number 2? Where it is now? Equation number 2. What is that? T2 by 300 is equal to what? RC to the 4 of what? Gamma minus 1. What is the value of T2? We don't know here also, right? I will substitute the value of T2 in the equation number 2. Now what is the T2? T2 I got it in terms of what? RC. Now I will substitute. Then what happens? Wherever it is there, right? T2. There I will substitute, that is here I am going to substitute value of T2 value divided by 300. Then the same thing, T2 this much I will substitute 300, but RC at left and right side both will be get cancelled. Sorry, not get cancelled, we can take it out. Okay, so now we do simplification. We are going to get 26.39 divided by RC is equal to RC, this value 1.4 minus 1, then it becomes 0.4. Then you can take it left and right side, RC is common, right? Then 26.39 I will keep it outside. Then this RC I will take this side. Then what happens? RC to the 4 of 0.4 into RC. Then what happens now? So this simplification we are going to get the value of RC, that is compression ratio, as 13.35, dear students. Now you know the value of RC. Once you know the value of RC, then I can calculate the T2. Okay, what is that T2? That already we know, right? T2 is equal to 1400, RC is there. To calculate the TT, I should know the value of what? RC. That RC we have calculated here. Substitute here now. T2 is equal to, here simplification, T2 simplified 7918.4 divided by RC. RC is how much? 10.35. Do simplification, you are going to get the value of T2 is equal to 765 Kelvin. 765 Kelvin. But you refer equation number 6. What is the equation number 6 that you can see here now? What is equation number 6 here now, dear students? That's equation number 6, variation of temperature versus pressure. We have the standard equation. What is that? T1 by T2 is equal to P1 by P2 to the power of gamma minus gamma divided by gamma. So then what I will do now? Now what is T1? That is 300. What is T2? That we already calculated, that I have substituted. What is P1? P1 is 1 bar. Then what is P2? P2 we don't know, I will keep it as it is. Then gamma I know, I will substitute all the values. Then only unknown is P2. Do simplification and you can get the value of P2, that is equal to 26.7 bar. If you got the value of P2 is equal to 26.7 bar, that is nothing but what? P3. Why it's so? Because heat addition is taking place at constant pressure process. Hence we are going to get the maximum pressure as 26.7 bar. That means we calculate the maximum pressure. Fine. Now next step, we need to calculate the efficiency per the diesel cycle. To calculate the efficiency per the diesel cycle, the equation is different. That equation we know already. We have derived the equation also. What is that equation? That is theta is equal to, this is the equation. But to calculate this, I should know the value of gamma, that is given, that is 1.4. RC, that we have calculated. Gamma again calculate, it is we know, but only one unknown is cutoff ratio. Cutoff ratio is equal to what? Rho. How to calculate that cutoff ratio? We know the equation. To calculate that cutoff ratio for diesel is V3 by V2, that is equal to T3 by T2. So what is T3 here now? You can either I can use this equation, either I can use this equation. Okay, fine. Now what you can do now? T3 by T2. What is T3? 1400. T2 is this much. Then you do simplification. You are going to get the cutoff ratio as 1.83. Then you substitute that rho value in this equation, equation number 7. Then what you can do? You can get the value of what? Efficiency. You can calculate the value of what? Efficiency directly. That's fine. Okay. Do simplification. You will get the efficiency. Fine. Now, once we done, what we can do? We can calculate the work output. To calculate that work output, as I told dear students, I need to calculate the work done. That is the work output per unit time. That means what? Per second, right? That is nothing but what? Power is equal to work done per second. To calculate this work done, we know the equation QS minus QR. What is QS? That is very important. Dear students, you are adding heat at constant pressure, hence Cp you are taking, but heat is getting rejected at constant volume, you are taking Cv. Then do simplification. Cp is 1.005 kilojoules per kg for air. Then Cv is also 0.718 kilojoules per kg Kelvin. These are the constant you have to remember. Now, to calculate the work done per unit time, we should know all the temperatures and value mCp and mCv. I will substitute all the values here. Now, m is equal to 1.005, T3 is 1400, T2 is equal to 765 minus m is equal to 0.71, because 1 kg I am taking it, that you can neglect. Cv is equal to 0.718 minus into bracket T4 is 700 minus T1 is 300. Do simplification, we are going to get the rate of work done per kg second is 350.9 kilojoules per. That is nothing but what? Power or work done. Then later you can compare both. Now we have calculated the things, dear students. Here efficiency, just a minute. Here efficiency, with help of this you can substitute all the values, you can get the efficiency. That efficiency value you can see here now. Efficiency value is how much? 55.55%. Okay, so now at the last, what you can do, once the calculation is done for both Otto cycle and diesel cycle, that you can compare the results. You can compare at the last. What is that? Compression ratio. Compression ratio for Otto cycle is 5.65, whereas diesel cycle having 10.35. The maximum pressure in the Otto cycle is 26.36, whereas in diesel cycle it is 26.7%. The efficiency of the Otto cycle is 50%, where efficiency of the diesel cycle is 55%, whereas rate of doing work, that means what, 287.5 kilojoules per second, but here it is 350.9. that, dear students, we can say efficiency, power production is of diesel cycle is greater than Otto cycle. Hence we are using diesel cycle more in application because it is having more thermal efficiency and more power production. Dear students, in this problem what we have done, we calculate a compression ratio for Otto as well as diesel, maximum pressure for Otto and diesel cycle, we have calculated efficiency for both Otto and diesel cycle, then rate of work done for Otto and diesel cycle, and we have compared. That we can see here now. This is how to solve the numerical, dear student. Yes, Otto cycle is done, then diesel cycle is done. Auto cycles we are using in lighter applications. You can take bike, car and all those things. Diesel cycle we can find in heavier applications like bus, lorries, trucks, JCBs and all we can consider. Okay. So hope, dear students, I hope you understood this problem. If you have any doubt, you can ask me. Okay. Dear students, here with a request you, please do subscribe my channel. Okay, like and comment and help me to do more and more such videos. Okay, your support will help me a lot. Thank you.